Imagine a silent starlit night, the kind where the sky feels like an endless canvas of possibilities. Somewhere out there, beyond the familiar twinkle of distant stars, a strange light streaks across the cosmos, hurtling toward our sun at a speed that defies comprehension. For the past month, every major telescope on Earth has been fixated on this enigmatic glow, a celestial visitor that has astronomers, scientists, and dreamers alike buzzing with questions. This is no ordinary space rock. This is 3I Atlas, the third interstellar object ever detected in our solar system, and it's rewriting everything we thought we knew about the universe. As it races closer to the sun, time is slipping away. Soon it will vanish behind our star's blinding light, leaving us with a cosmic puzzle that demands answers. What is this thing? Where did it come from? And could it, dare we ask, be a sign of something more? Buckle up, because this is a story of mystery, discovery, and the tantalizing unknown, and it's one you won't want to miss. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, first caught sight of this strange object nestled between the orbits of Jupiter and Mars, though closer to the gas giant. Officially dubbed 3I Atlas, a nod to its status as the third interstellar object ever observed. It hails from a distant corner of the Milky Way, possibly a solar system twice as old as our own. This isn't just a rock from our cosmic backyard, it's a traveler from another star, a relic from a place so ancient it makes our 4.6 billion year old sun look like a newborn. The discovery sent ripples through the scientific community, not just because it's rare. Only 2 other interstellar objects have ever been spotted, but because 3I Atlas is proving to be unlike anything we've seen before. To put this in perspective, let's rewind to 2017, when the first interstellar visitor, Oumuamua, tumbled into our solar system. Shaped like a cigar and moving in ways that baffled astronomers, Oumuamua sparked endless debates. Was it a comet, an asteroid, or, whispered in speculative corners, something artificial? We still don't know, but its odd behavior left an indelible mark. Then came 2I Borisov in 2019, the middle child of interstellar objects. Unlike its quirky predecessor, Borisov behaved like a textbook comet, complete with a familiar tail and predictable icy outbursts. It was strange in its familiarity, a cosmic guess that played by the rules. But 3I Atlas, it's in a league of its own, defying expectations and raising questions that grow stranger with every observation. What makes this object so captivating is its speed. When NASA's Voyager probe set out for Jupiter in the 1970s, it took them 18 to 23 months to reach the planet's orbit. 3I Atlas, however, was spotted near Saturn in May 2025 by the Transiting Exoplanet Survey Satellite, TESS, which was originally hunting for distant alien worlds. By July, it was already closing in on Mars, and it's projected to make its closest approach to the sun on October 29th, 2025. By next spring, it will zip back out to Jupiter's orbit, untethered by our sun's gravity. This breakneck pace, known as a hyperbolic trajectory, confirms its interstellar origins. It's moving too fast to belong to our solar system, a fleeting visitor passing through on a one-way ticket to the stars. The first clue that 3I Atlas was no ordinary comet came from those early TESS observations. On May 7th, 2025, when the object was still beyond Jupiter's orbit, it was already glowing with an unusual brilliance. Comets as we know them are typically chunks of frozen water, dust, and gas that lurk at the edges of our solar system. As they approach the sun, the heat causes the ice to sublimate, turning directly into gas in the vacuum of space, forming a glowing halo called a coma. This process usually kicks in closer to the asteroid belt between Mars and Jupiter, but 3I Atlas was already shining brightly, its light intensifying daily, even when it was farther out than Jupiter. This early sublimation hinted at something extraordinary. If this is a comet, it's not like any we've seen before. As astronomers trained more telescopes on the object through July and August, the mystery deepened. A tail began to form, a common feature for comets as solar wind. The constant stream of charged particles from the sun pushes the coma's gas and dust into a glowing trail. But 3I Atlas's tail was growing in the wrong direction. Instead of trailing away from the sun as every comet tail should, it was pointing toward it, defying the solar wind's relentless push. Picture a dog sticking its head out of a car window, only for its ears to flap forward instead of back. It's not just unusual, it's downright bizarre. This anomaly alone was enough to make astronomers sit up and take notice, prompting them to aim the world's most advanced observatories at this cosmic oddity. By late summer 2025, the scientific community was in overdrive. The Hubble Space Telescope, the James Webb Space Telescope, the cone-shaped SPHEREx satellite, and TESS were all redirected to study 3I Atlas. These instruments, designed to peer into the farthest reaches of the universe, were now focused on a single point of light racing through our solar system. The results were staggering. NASA's most advanced observatory revealed that the coma surrounding 3I Atlas is composed almost entirely of carbon dioxide, CO2, with a ratio of CO2 to water, H2O, of 8 to 1, 16 times more CO2 than a typical comet. This massive cloud, stretching up to 300,000 kilometers in radius, is nearly half the size of the sun itself. For context, that's larger than most comets' comas, which already dwarf their solid cores. Speaking of cores, early estimates pegged 3I Atlas's solid center at about 20 kilometers wide, then revised down to 11 kilometers. But new data suggests it could be as large as 46 kilometers, a significant size, though not unprecedented. What is unprecedented is the object's composition. Unlike the water-rich comets of our solar system, 3I Atlas is dominated by CO2, a clue that it formed in a star system with wildly different raw materials. This isn't just a visitor from another star, it's a product of an alien chemistry, a snapshot of a distant world where the building blocks of creation differ from our own. As if the CO2 dominance and backward tail weren't strange enough, another discovery sent shockwaves through the scientific community. In August 2025, the Very Large Telescope, VLT, in Chile, a fittingly named behemoth of an instrument, detected something astonishing in 3I Atlas's coma: nickel metal, but no trace of iron. This is where things get truly wild. In the universe, nickel and iron are cosmic best friends, forged together in the hearts of dying stars and scattered across space by supernova explosions. You rarely find one without the other in natural settings like asteroids, moons, or planetary cores. The only time nickel appears alone is when humans deliberately separate it through industrial processes. So how did 3I Atlas end up with nickel but no iron? It's a question that defies easy answers and has sparked a flurry of speculation. Could this be evidence of something artificial? The idea isn't as far-fetched as it might sound. The brightness of 3I Atlas as it passed Jupiter, far beyond the point where most comets begin to glow, could be explained by its high CO2 content, or it could suggest something else entirely. Some theorists propose that the object might be an alien probe, its increasing brightness the result of lights or systems activating as it approaches the sun. Others speculate that the CO2 cloud could be exhaust from a massive spacecraft, perhaps carrying living organisms that exhale CO2, venting it into space like a cosmic breath. There's even a theory that 3I Atlas itself might be a living entity, consuming interstellar dust and gas, and releasing CO2 as a byproduct. These ideas, while speculative, can't be entirely dismissed. Not yet. The nickel anomaly, the backward tail, the CO2 dominance, all of it points to something profoundly alien in every sense of the word. The deeper we dive into the mystery of 3I Atlas, the more it challenges our understanding of the cosmos. The object's peculiarities don't just stop at its chemistry or trajectory, they extend to its very behavior in our solar system. As it barreled past Jupiter, its brightness surged far beyond what astronomers expected, even accounting for its proximity to the sun. This unexpected luminosity has led to heated debates in observatories and online forums alike. Some argue it's the result of an unusually high albedo, its surface reflecting sunlight like a cosmic mirror. Others point to the massive CO2 coma, suggesting that the sublimation process is releasing particles that scatter light in ways we've never seen. But there's a quieter, more daring hypothesis circulating. What if 3I Atlas is actively emitting light, not as a natural reflection, but as a deliberate signal, a beacon from a civilization long gone, or perhaps still watching from afar? This idea, while on the fringe, gains traction from the object's other anomalies. The backward tail, for instance, could be the result of an unknown propulsion mechanism pushing against the solar wind in ways that defy our physics. Imagine a spacecraft, its engines firing in a way that mimics a comet's tail, but with a purpose we can't yet grasp. The nickel anomaly only fuels this speculation. After all, a manufactured object might use purified metals in ways nature never would. As we approach the critical October window, scientists are racing to collect spectral data that might reveal more about the object's surface composition. Is it a rocky core, a metallic hull, or something entirely new? Every new observation adds a piece to the puzzle, but the picture remains tantalizingly incomplete, pulling us deeper into the enigma with each passing day. The story of Three Eye Atlas is as much about humanity as it is about the cosmos. Across the globe, teams of astronomers, engineers, and data analysts are working around the clock, their eyes glued to screens filled with numbers, images, and spectra. In Chile, the VLT hums under the starlit Atacama Desert, its mirrors capturing faint glimmers of light from a visitor that may never return. In mission control rooms, engineers adjust the trajectories of spacecraft like Mars Express and Juno, hoping to steal a glimpse of this interstellar wanderer. This collective effort is a testament to our insatiable curiosity, a drive that has propelled us from gazing at the stars to sending probes across the solar system. But it's not just scientists who are captivated. From amateur stargazers to online communities, people everywhere are sharing theories, sketching diagrams, and debating what Three Eye Atlas might mean for our place in the universe. Some see it as a reminder of how small we are, a fleeting speck in the vastness of space. Others find hope in its strangeness, a hint that we might not be alone. The object's rapid approach has sparked a global conversation, uniting people across cultures and continents in a shared quest for understanding. As we await the Mars flyby in early October, the anticipation is palpable. Will the images reveal a jagged, natural rock or something with unnervingly smooth edges? Will the data confirm a comet-like origin, or will it deepen the mystery with hints of artificial design? This moment feels like a crossroads in human history, a chance to touch the unknown and redefine what we believe is possible. As Three Eye Atlas nears its closest approach to the sun, its legacy is already taking shape. This isn't just another astronomical event, it's a milestone that could redefine how we study interstellar objects. The data collected from this visitor will fuel research for decades, offering insights into the chemistry of distant star systems and the processes that shape cosmic travelers. If Three Eye Atlas is indeed a comet, its unique CO2-heavy composition will force us to rethink how comets form and survive in alien environments. If it's something more, well, the implications are staggering. A single photograph, a single spectrum could upend our understanding of life in the universe. Even if it turns out to be a natural object, its anomalies will inspire new theories, new technologies, and new missions to chase down the next interstellar visitor. The Juno spacecraft, nearing the end of its mission, represents a final poetic chance to connect with this object. Repurposing it for an intercept would be a bold move, a fitting capstone to a mission that has already revealed so much about Jupiter. But beyond the science, Three Eye Atlas is a story of wonder, a spark that ignites our imagination. It reminds us that the universe is vast, strange, and full of secrets waiting to be uncovered. As it slips away from our solar system, it leaves behind a challenge to keep exploring, to keep questioning, and to never stop looking up. What will we learn from this cosmic visitor? And what will it teach us about ourselves? The answers are out there, waiting in the stars. The enigma of Three Eye Atlas stretches beyond its immediate oddities to touch the very origins of the universe itself. Scientists estimate that this object could have originated in a star system twice the age of our own, potentially dating back 9 to 10 billion years. To grasp the significance of this, consider that our sun is a relatively young star in cosmic terms, formed from the remnants of earlier stellar generations. Three Eye Atlas may carry within its structure the chemical fingerprints of a primordial era, a time when the Milky Way was still forming, its stars forging the heavy elements that would eventually give rise to planets, comets, and perhaps life. The high CO2 content, so alien compared to our water-rich comets, suggests a formation environment where carbon dioxide dominated over water, perhaps near a star with a different composition, or in a region of space where volatile gases behave differently. This raises profound questions about the diversity of planetary systems. Could Three Eye Atlas have been ejected from a system where CO2-based chemistry fostered unique forms of matter, or even life? The nickel anomaly adds another layer, hinting at processes that might involve stellar nucleosynthesis or even artificial manipulation. Imagine a star system where massive stars exploded billions of years ago, scattering nickel-rich debris that somehow coalesced without iron. Or picture a civilization advanced enough to refine metals in space, leaving behind a relic that now drifts through our solar system. These possibilities, while speculative, are grounded in the data we've collected, and they push us to rethink the conditions under which cosmic objects form. As Three Eye Atlas speeds toward the sun, it's not just a visitor, it's a time capsule, carrying clues about the ancient universe, and challenging us to decode its story before it vanishes forever. The trajectory of 3i Atlas is a cosmic ballet, a high-speed dance through our solar system that captivates astronomers and laypeople alike. Its hyperbolic path, unbound by the sun's gravity, sets it apart from the orderly orbits of planets and comets in our neighborhood. This object is a rogue, a wanderer that has likely traveled for millions, if not billions, of years across the vast gulfs of interstellar space. Its journey through our solar system is a fleeting moment in its long existence, yet it's giving us a front-row seat to a spectacle of physics and mystery. As it passed Saturn in May 2025, it was already moving faster than any spacecraft we've ever built, covering the distance to Mars in just a few months. This speed, combined with its unusual brightness and tail orientation, suggests interactions with our solar system that we don't fully understand. For instance, some researchers hypothesize that 3i Atlas might be experiencing a form of outgassing that's influenced by forces other than solar wind, perhaps magnetic fields or internal processes we've yet to identify. The backward tail pointing toward the sun could indicate a complex interplay of particles, where the object's own momentum or composition overrides the sun's influence. Alternatively, it might suggest an asymmetrical structure, where one side of the object releases more gas than the other, creating an unexpected thrust. These dynamics are being modeled in supercomputers as scientists race to predict how 3i Atlas will behave during its upcoming Mars flyby and perihelion. Each observation is a chance to refine these models, to learn not just about this object, but about the fundamental laws that govern motion and matter in space. The dance of 3i Atlas is a reminder that the universe is a place of constant motion where even the strangest visitors follow rules. Rules we're only beginning to understand. The global fascination with 3i Atlas transcends borders, disciplines, and perspectives, uniting humanity in a shared quest for knowledge. From the control rooms of NASA and the European Space Agency to the backyard telescopes of amateur astronomers, this object has ignited a spark of curiosity that burns brightly across the globe. Social media platforms are abuzz with discussions, where people from all walks of life share their hopes, fears, and theories about what 3i Atlas might be. Some envision it as a natural wonder, a comet-like object shaped by eons of cosmic forces. Others dream of it as a message from an alien civilization, a probe sent to explore or observe. These conversations playing out in comment sections and virtual forums reflect the diversity of human thought, from the rigorously scientific to the wildly imaginative. Schools are incorporating 3i Atlas into lesson plans, inspiring the next generation to look to the stars. Artists are creating illustrations and animations, bringing the object's journey to life in vivid color. Even philosophers are weighing in, pondering what the discovery of an artificial object would mean for our understanding of existence. This collective wonder is a powerful force, driving collaboration and innovation. The upcoming Mars flyby on October 5th, 2025 will be a global event with live streams and updates shared in real time, inviting everyone to witness the moment. Whether 3i Atlas turns out to be a natural phenomenon or something more, its impact on humanity is undeniable. It's a reminder that the universe is a shared frontier, and our curiosity is the key that unlocks its secrets. As we watch this object streak across our skies, we're not just observers, we're participants in a cosmic story that's still being written. With 3i Atlas hurtling toward the sun, time is of the essence. On October 5th, 2025, the object will pass within 28 million kilometers of Mars, far enough to avoid any danger but close enough for two European Space Agency ESA orbiters, Mars Express and ExoMars Trace Gas Orbiter, to capture high-resolution images. These won't be close-up portraits, but they should offer enough detail to distinguish the solid core from the surrounding gas cloud, potentially revealing the object's shape. Is it a jagged rock, a smooth sphere, or something stranger? The answer could provide critical clues about its nature. By October 29th, 2025, 3i Atlas will reach its closest approach to the sun, a moment known as perihelion. After that, it will swing behind our star, disappearing from Earth's view until December. When it reemerges, it will already be on its way out of the solar system, never to return, but there's one final opportunity to study it up close. On March 16th, 2026, 3i Atlas will pass within 53 million kilometers of Jupiter, still a considerable distance, but within reach of NASA's Juno spacecraft, which has been orbiting the gas giant since 2016. Originally slated to end its mission in September 2025 by crashing into Jupiter, Juno could be repurposed for a daring intercept mission, offering a last chance to gather data on this cosmic enigma. The story of 3i Atlas is more than a scientific curiosity. It's a reminder of how little we know about the universe and how much there is left to discover. Each observation brings new answers, but also new questions, fueling our collective sense of wonder. Is it a comet, an asteroid, or something we can't yet comprehend? The possibility, however remote, that it could be artificial taps into our deepest hopes and fears about our place in the cosmos. Are we alone, or is the universe teeming with life? Perhaps even civilizations advanced enough to send probes across the stars. This mystery also underscores the power of human curiosity. From the astronomers analyzing data in Chile to the engineers guiding spacecraft around Mars and Jupiter, the global effort to understand 3i Atlas is a testament to our drive to explore the unknown. It's a story that connects us all, whether you're a scientist peering through a telescope or a dreamer gazing at the night sky. As 3i Atlas races through our solar system, it's a once-in-a-lifetime chance to witness history in the making. What do you think this object could be? A relic from an ancient star system, a natural oddity, or something more? Share your thoughts in the comments below. Your ideas might spark the next big theory. If this story has ignited your curiosity, give it a thumbs up to spread the word and keep the conversation going. Subscribe for more updates on 3i Atlas and other cosmic mysteries, because the universe is full of surprises, and we're just getting started. The clock is ticking. By late October, 3i Atlas will slip behind the sun, and our window to study it will narrow. But until then, the world's greatest minds and machines are working tirelessly to unravel its secrets. Will we find definitive answers, or will this interstellar visitor leave us with more questions than ever? One thing is certain, the journey to understand 3i Atlas is a thrilling ride, and we're all along for it. Stay curious, keep looking up, and let's see where this cosmic adventure takes us next.